Hello, it's Chris from LearnGrasshopper.com bringing you a unique lesson today. In this video, you will discover how we can manipulate Tekla elements already present in your model. Whenever you are manually crafted objects within Tekla or generated them through LiveLink, you can use Grasshopper to make changes that are not possible to do just with Tekla. This lesson is one of the middle lessons from my comprehensive Grasshopper in Tekla training, where I take a Tekla user with basic Grasshopper knowledge and go step by step through 10 well-structured modules with many practical case studies. The Grasshopper in Tekla training provides a complete roadmap for automating repetitive tasks in Tekla structures that currently consume much of your workday. At grasshopperintekla.com you can sign up for the next edition of this online training and reserve your seat. You will be added to my mailing list and I will let you know when the next edition starts and come up with the best possible offer. Now, let's dive into modifying Tekla elements with Grasshopper. Hello! All of components that I'm going to present in the following lesson completely change my perspective, how I see working with Grasshopper and Tekla looks like. Before, I was really amused about all examples like really complex shapes, facades, and really like a roof structure, and you can just send it to Tekla and create everything. But actually, not that many projects can be done 100% in Grasshopper. Most of our work we have to do manually. And the modify ribbon completely changed that, because you can modify already existing objects in Tekla. You can modify everything which was modeled manually. And this completely can give you a new perspective how you can model manually, but still maybe some repetitive tasks you can modify in Grasshopper. So first component of that is a modify beam. Beam this means that all the beam type objects, so beam, column, panel, and footing. Grasshopper this component doesn't have any memory, so you have to be careful with that one, because if you modify this one, connecting your beam and maybe changing your curve, you cannot undo this in Grasshopper. You have to go into Tekla structure and undo there. So this can be really tricky, and think twice before connecting all the data and save your model, because we can really destroy that with that component, but another side is really powerful. Second one is a modify item. Here you can change your geometry, you can change your profiles, attributes, and so on. Before it was you can show internalize in Tekla, but here we have also mesh color, so we can also see the mesh which we are sending inside Tekla. Next one is a modify plate. In addition to that, you can change boundary, profile, attribute, position, and numbering. If you right click, you can also change the maximum control points. So for example, if there was some plates created before in the several places, so we can connect them and change the maximum control points for all of the existing plates. And last one will be about reinforcement, modifying rebar group. I will show you some cool examples. I think this is really a game changer for modifying the rebars and giving a new shape, new range, new attributes. Adding hooks can be really beneficial. And as it was before, we can also play here with the maximum control points. And modify a single bar, of course, if some of you are keen to use that component, so you can also modify single bars. That's all of theory. Let's go to Tekla and let's play with modifying some objects. Let's have some fun and play with the real examples. So first one, it will be about the columns. Let's say that we have a change on the project, so this particular roof will be moved, let's say 250 millimeters up. So we have to adjust all the columns, and of course we can do it manually. Just make a line and make where they are going into each other, or maybe make a cut. But now let's make it parametric. So we have all the columns that are around. Let's zoom that. So we have this column. We can deconstruct beam, just make a beam deconstruct, and we can get all the curves. So we will get all the curves. So let's zoom it, and here we have all the curves. Let's also take a plate deconstruct, so we can take the roof structure from the top. So let's take it into our Grasshopper. Okay, so we have this one, and this we have another one, and now we can just extend our curve. This is so easy. So we can just take a curve. We have the start, we have the end. So start, it will be 0. We are not going to extend at the start, and at the end, let's extend it 1 meter. Yeah, maybe 1 meter. So let's extend that. So we can see that everything looks good in this case. So it's going into the upper position. Let's do like that. So we have maybe even we can do even more. So let's go 500, so we can see the difference. So now we can see that this is a plane. So we can use the boundary. So we use that as a planar. So we can get the plane, planar. So we will get the plane, so that's it. And we can find the plane and curve and plane. So we have all the curves, we have one plane. So this will be the plane, and we will get all the points. So here we have all the points from this particular case. And in this one, we are going to use shorter. So we can take all our curve and parameters on the plane on the curve. So this is how we are going to split, and we are going to take the first as a line. So we will have all our lines, and now we can modify. Before connection, I always like to rebuild our curve. So everything is alright. That is a count. Let's say that we have just 2. It's a linear object. So I always try to do that. So let's connect that. Let's connect our model of our columns, and let's connect our curves. So you will see that we have extended. Okay, maybe it's still a bit, I'm not sure why it's that long. Maybe it's about the plane is not positioned correctly, but this is not a problem. We can always change our plane, so we can see this is the plane, and we can define that with our for example curve. So we can do polyline, and let's go to Tekla, and let's go to our Tekla polyline. And if we are going to create just 3 points, so let's say start and the second. So we can create a line. Let's change that into curve. So perfect. So now we can see that we have every single column going to our object. So that's looking good. This is what I've been expecting. Let's go to next one. Next one is about the walls. Here we have, in this example, we have 232 walls, and I would like to check the volume of these objects. So we can, or weight, volume or the weight. So we can go to property, get a property. We can try, maybe, I'm not sure, weight. Okay, let's see if we have something. We have the weight of that one. Maybe I will just find another property. Let me check why it's 0 for that. Let's go to inquire part. Okay, it's a 0 kilogram because it's the material is not defined that with the kilos. So let's take the weight. Let's take the volume net. I think it will also work fine. Let's see, what do we have here? We have different weights, so we can see right now. Let's create a set. Create a set. This component can be found in the sets, and let's create that. So we can have 152 groups. There are many groups, so let's change that. Let me see. We can maybe divide that 1000 to check the divide. Just make the divide so we can see that one. And so looks good. And maybe we can also make some grouping that with some tolerances. Let's maybe use the factor. So let's use the round to factor, and maybe we can just round a little bit as we have more values. So let's say for 0 cubic, let's say 0.25 maybe 0.25. So we are going to round that. So rounded values, so it looks better. So we have rounded values, and let's create a set from that. So we can see, let's use that as a number. So we can create a set with the number. Okay, so we have now some sets, 17, so that looks good. So we have different, so this is the rounded, so we can say that this is our tolerances. For that, we are going to use member index. We are going to take all of this, our set and our member. So we have all the data structure, so we can see here. So we have all elements. That looks good. We have also the count, which group it is. So that looks good. We have the index number. So now we can take all the groups and place them. So maybe we can just change the color of the groups. So let's change the color. So modify beam. We are going to take all our beams from that one, and we would like to also create data tree, so tree statistic. We have to know how many colors it will be. So here and the paths, so we are going to have 17 paths, so length, list length, so we know list length. So we know that is a 17 values, so let's create a series that starts with, for example, 100, goes every one step and go with the 17. Okay, so we have 17 classes, and now we have to group all the elements. Let's say like we have to list all our elements. So let's list them as our index number. So let's list that in this order. And we can find that we have all the panel listed. So we have listed, so they should supposed to be in the correct order. And now we are going to create the same number of series. So this one we are going to graft to get the data tree, and we are going to repeat data. Repeat data, we will take tree statistics. Tree statistics. To do that, and we have the length of every single data. So we have the data and the length of every single branch. We are going to graft it. So now we have 232. So let's disable that. Let's connect this data structure and another data structure as our attribute, and part attribute. So let's connect that. We are going to connect that into the class. So we will get 232. So let's flatten that. We can also make a flatten. So if we are sure that it's the order is correct. And now let's try. Let's try and let's enable, and perfect. So now we can see that all the volumes they are together. So we can see that they are in the same group, they are the same volumes. If you are making some assembly plan, it can be really beneficial to just group them into the correct. So we can see that this is a volume, this is the same group because the opening, but it's everything by this value, this factor. If we are going to change that to, for example, 0.5, so just only 5%, so we will see it, everything will change color and it will be the little bit different. We have the here we have the length. Okay, this is the length, but we can also change to the weight. So let's try it. It was 0, so it was volume. let's create that. It was the volume. Let's create how many sets was it's 125, and we can just round it, and maybe just round it. It will be not 0.25 but 250 maybe. Connect that factor. Let's change this factor maybe a little bit bigger, so we have a huge difference. So we can see that there are more a small number of groups. It's just 53. So we can see that these three walls are the same. This one is not, because in the first floor is higher. So it looks like everything is working. So you can play that, and with the assembly plans, so we can easily plan everything by the weight, by the angle, by the volume, area, and so on. So let's go to next example. Next one, it will be about the plates. So we have the four different boundaries here. I will take all these curves. Let's connect that. So we have four different boundaries. So let's create that. Let's zoom, and let's zoom selected. We have it here. Let's give some thickness to this profile, so we can see profile, let's say 500. Okay, so now, but you will see that every single of them has a different starting point in a different way. Here's the starting point, here's the starting point, here's the starting point, and here's the starting point. So the thing that we can do is to change this starting point. And this is because if we go to endpoints, we will see that the endpoint start and the endpoints are in the different places. So let's start just one of them. So we can play a little bit. We can modify our plate. So let's modify that. Let's connect that, and we are going to change our boundary. We're going to check this discontinuity of this curve. So we have parameters and 4 parameters, and we are going to change the seam. This is our seam curve. So our seam is the place where curves closed polyline starts and ends. So we can specify that by the parameters. So we can list it. So let's list first one and the seam. Let's change that so we can see if something is changing. So we are having just one of this plate. And now let's modify that. It's a new boundary. So now if we are going to take closer look on that, so we will see that this is changing. So this is a perfect way to just specify where the seam is placed. But let's go to the situation that we would like to automate that one. So let's create the profiles from the previous example. So we are going to select all of the curves. We are going to connect that to our automated way. And now let's go through the script. Same principles as it was before. First, we deconstruct our 4 plates with the different seams. And with the discontinuity, we can find the all corners. Here we will see the data tree with the 4 points in every 4 elements. Next one is that we are creating the planes for every single curve. So this curve has its own plane. In every scene, you can see that they are in the different position. It always depends on where the seam is. So let's now go now and place this plane in the center. So we can see that this plane it will be in the center, and let's make a circle around that. So maybe I will just disable all the rest of components. So now we have the circle in every single middle of the rectangular. The next one is we are going to find a curve closest point. So we are going to move that. So you will see that we are finding for every single curve. So let me see. I will going to graph that. So we will see that we have found the closest position. So this point becomes this one, this point becomes this one, and so on. Next step is to find the closest point. So we have the cloud of our points, and we are going to move one of the centroids in one of the axes. and we can find the closest point to this one. So this is just, we just prefer which corner it will be. So for example, let's say that it will be in this way. I will show you that we can play a little bit with that one, so we can rotate it. So in this way, we can find it which point is closer to which one. So we can just, in this way, we can steer which point it will be the new sim. And when we find the closest point, so we can see the closest point lists. So the first one, it will be the closest, and the distance, sorry, so it will be the distance here. So we can find which one was the closest, and with the index, we can also see that one. And at the end, we can list all of these points that are on the parameters and set up for our sim as it was before for every single curve. So let me see, there's a data tree structure, and let me see, we are going to choose just the first one. So let's use the first one, and now let's go to flatten. So this is the sim parameter and the curve parameter. Okay, and now let's take a look on that, and you will see that here in the automatic way we have changed every single trait that they have a point in this one. If we're going to change this script, so play a little bit with this radius, so we will see that this is jumping. It's jumping before 1 second, third, and so on. Next example with reinforcement. So here it's a reinforcement from the tunnel. So let's zoom it into Tekla, so I can just show only selected. Just a reminder, here we have the curve reinforcement placed with some offset, and if we go to inquire, so we can see that we have the same length, sorry. And our aim is to create a little bit bigger, so it will be a little bit longer on one side, so they will be with the tapered form. We are going to modify rebar group, so we are going to modify this group, so we can see that we have two curves that we have implemented, and we are going to extend one of the curves. So I will take a look on that one. Here I will change to perspective, so we can see this curve. So we have one curve on the one side here, and the second, the one we are going to extend. So maybe we can extend it a little bit more. So let's extend that, and it will be the arc. So we are going to extend it on the arc. So that looks good, and as before, we are going to change it into arc, so everything is explicit, and we have the really nice arc. And now we are going to merge these two lines, and without shape as a grafted, we are going to connect the first one. So it will be the second one and the first one. So let's connect that and see if something is changing right here. The part, I think it will be the same, the part will be connected, so let's keep it. And the shape, we are going to connect that. Now we can see that we have modified the rebar group. We can change the number of points, maybe to 30. Sorry for the sound. Now we are in this group. Okay, so now we have this tapered, but let me see that every single bar is different. So let's modify this even better. So we can maybe check and group it for every single bar of the same length. Let's say that we would like to create just two groups. So two different groups with the same length. So kind of interpolation between them. To do that, we are going to extend. First of all, let's assume that we do not have this part of the script. Let's expand object. Let's expand that. So from that one, or even go better, maybe just to that you will see that we are not having that parametric. So I will take this one and I will take it as an object. And from that one, we can get the information about the polygon. So here we have the polygons, two Tekla polygons. We can expand it even more. So let's expand it, our polygon. Here it will say we'll get the points. So let's extend these points, and we can get X, Y, Z. So construct point, and let's connect X, Y, and Z. we have points right here. Let's shift our list so we will get that. We have 30 points. That looks good. And let's interpolate that. Okay, so now we have the same input as we get before. Let's check the length of this curve. So we are going to go to length. We are going to flatten this list and, oh, maybe not, just showing the results. So we have one length and another. Now we are going to split this reinforcement. So the aim is to split this reinforcement in the same groups of the same length, going from the smallest. So let's say in the four different parts with the same length. So we are going to keep this reinforcement, and now we are going to use a component called twin curve. So we are going to twin between first one and the last one. So we will take the list, the first and the last. We are going to use that first and the second, and we are using our factor as a default is 0.5, but we can go to the range. And in domain 0 to 1, we are going to use steps. Let's say that we are going to divide into 4 parts. Let's go to range right now and factor. And now we will see that we have the first, second, third, fourth, and fifth. Okay, so now we are going to create 4 groups. We have 5 planar. And for that, we are going to use component shift list. That we are going to shift list with the -1 and 1. Let me see, I will just show you. So we have the shift and we are going to wrap it out, so false. So this is the first group, and the second group, it will be with the 1 going into 1. Okay, so now we can merge that into, for example, we can wave into the 4 groups. So let's see pattern 0, 1, 0, 1. Let's go 1 and second one. Let's go graft it. So we are going to graph this one and graft this one, and as a result we have groups of data. Let me see. Here maybe I will just explode 3 and just show you the first group. So here this is the first group. And okay, this looks good, but let me check the lengths, because we just grouped them, but we have to use the same. The aim was to use the same lengths, and now we can see that we have different groups, different lengths, and the aim was to have the longest one. So we are going to take the longest length and extend that with the shortest one. So if we're going to extend our curve, so let's come back to our data tree. So we are going to go to the curve, and we are going to extend that. So type, let's say that is an arc. We are still operating on the arcs, and the difference between the longest and the shortest. So let's take the first item and the second item, and let's make a difference. What is the distance between the longest and the shortest? So let's say, so this is our difference. And now this one we are going to extend in the both ends. So we are going to divide it by 2. So let's connect that. Let's create. So we are going to extend that for the one direction and the second direction. So let's, here we have the data tree structure. So the first one, and so the first curve will be not extended. So let's take this one. So the first one will be not extended. We are going to extend the second one. So here, the second one, which is the shorter one. And now with the type, we are going to go to start and into the end. So now I can see, and we will see what is if we're going to merge them again, first and the second, and we are going to see the lengths of it. So let's take the lengths of them. Let's connect that. So we will see that they are exact the same length. So this is what we actually wanted. So now we have the 4 groups. And now let's create, based on that, we can modify. Let's just modify this rebar. So I'm not sure if they will be created, but let's try. we are going to modify a rebar group. We are not going to, yeah, this should supposed to be good data tree structure, so we can graft it. Now let's connect this bar group into bar group, and now let's finger crossed and go connect to the shape. We can see what is wrong. System explained failed to insert or modify rebar group. Polygons have different numbers of points. This can happen, and as I already showed, this may probably we have to rebuild our curve, because when we are going to extend that, so maybe we are going to change. So let's make a curve. Let's change the count into, for example, 20. Let's connect that one, false, and let's connect the shape. Okay, I see right now that something is changed, but the thing is that we have just one rebar group. Okay, let me see, let's check this rebar group. Okay, this looks good, the same length. We can change the number of points into, let's say, 20. So I have the rebar, but just only one rebar group, and this is because we have just one rebar group here. Maybe we can just duplicate the data. Let me see, I will try to duplicate this data, and with the number of steps. Let me see, I'm not sure if we are going to duplicate that. No, it's just creating the first one. So let's going to graft that. Okay, so now we cannot just modify one, because when we are modifying just one rebar, so we have to also create the second one. Let's cheat a little bit here. What will happen if I will copy this one and I will copy 3 times in the same position? Okay, keep the duplicates. And now I will take all the model object and will take all the rebars. So let me check, set multiple objects, take the rebars. We have 4 different groups, and without any grafting, we can just click it. Now we have modified the same rebar, and we'll see the difference. So let's make again the reinforcement from before. Let me see, I will just point it out. So now, instead of having this reinforcement that is going tapered form, we have changed into the different heights, different lengths, sorry. So this is really cool way to simplify your reinforcement. And if we go to inquire, so we have the same length. And of course, we can play a little bit, we can get even more. Here I cheated just a little bit, but we can also try to just delete this one and delete this object. So we have all these groups, and we can try to just create just bar group, just rebar group. And now let's connect the shape, so it will be the same. Here will be the shape, and the part, it will be the same part that we modeled here. So this will be the part. So if we model just right once again, so we will get here like 4 groups. So now we can see it, and let's change again the number of points, let's say to 25. And now if I'm going to change the step, so here I'm changing the step, so I'm going to be more precise. So this is really awesome. I really like it, this approach. And now we can see with the show only selected how cool this method is, that we can divide it with the equal rebars. So that's it for modify group. I hope you will enjoy it and start to using on the existing elements. That's all, and see you in the next video. Directly beneath the video, find links to the presentation in the PDF format and Grasshopper exercises made to this lesson. Dive into practice right after watching with free access to both the PDF and Grasshopper file. If you found this video useful and practical, please like it, share it with anyone eager to develop solutions for the most challenging Tekla problems or automate tedious tasks. Perhaps this video might inspire a shift to a smarter way of working with Tekla. Head over now to grasshopperintekla.com to sign up to our next edition and grab the best deal. Looking forward to seeing you on the platform. Have a good one!